Hello friends, this is Jim with Science Talk. I want to discuss with you one of the consequences of increasing planetary temperatures. Namely, that humans, and animals, but humans will be facing a cooling crisis. What is meant by that? Well, the planet continues to warm. Humans need to keep where they are at cooler so that they can have tolerable conditions. And to keep places cool, you're going to run fans, you're going to run air conditioners. They need energy. So this is a great irony. You are increasing temperature worldwide. The planet's becoming hotter. The demand for energy to stay cool goes up. And that means you're going to burn more fossil fuels to run these devices to cool down, adding more emissions to the atmosphere, in essence creating a feedback loop. A positive feedback loop, which is a reinforcing one, tending to exacerbate a given situation. So, in a report by the International Energy Agency, the IEA, on the future of cooling, the agency's executive director, Fatih Birol, sums up the problem as such. The world faces a looming cold crunch. This is some data from the IEA report, using air conditioners and electric fans to stay cool accounts for nearly 20% of the total electricity used in buildings around the world today. This trend will continue to grow as the world's economic and demographic growth becomes more focused in hotter locations. So, silly little pop-ups. Sorry about that. So, since 1990, the report says, global sales of electrically powered fans and air conditioning systems have more than tripled. More than half of them are used in just two countries. Guess which two? China and the US. Over a year, the 1.6 billion air conditioners in use worldwide consume more than 2,000 terawatt hours of electricity, which is 2.5 times more than Africa's total annual electricity consumption, the entire continent of Africa. CO2, carbon dioxide emissions from cooling, have also tripled since 1990 to 1,130 million tons, basically 1.13 billion tons of CO2. We know what that means. Most of the projected growth by 2050 in energy use for cooling is expected to come from the emerging economies, such as places like India, China, and Indonesia. The IEA says its analysis shows that government policies to address current and future electricity consumption so as to meet cooling demand would have only a very limited effect in slowing it. Its baseline scenario sees the energy needed tripling by the year 2050 to 6,200 terawatt hours. That's huge. And with that goes the increased addition of CO2 being pumped into the atmosphere. So what's needed here? Well, we need efficient stuff. Okay? We need more energy savings. We need to change the way buildings are designed and constructed, as well as what materials are used in the construction. Now, if you look in the Middle East, where it tends to be hot, there is a long tradition of constructing buildings that incorporate what's called wind catchers, which use natural airflows to ventilate the buildings and have even been used for refrigeration. Painting buildings white just to reflect sunlight helps. every year when I have, up here in Alaska, we get snow and all that kind of stuff there. What I do is down towards the end of my driveway, where I know I'm not going to drive my vehicle, I cut out a nice square patch of the compacted snow to get down to the rocks. Because when I have the rocks there, the rocks start absorbing the heat and help melt the rest of my driveway, whereas this solid snow, it will take a little longer because the snow is reflecting the energy. Right? It's called the albedo effect. Antarctica has a high albedo effect because the white ice reflects a lot of sunlight energy back into space. So it's sort of a mini albedo experiment I do here in my driveway. But when you paint your buildings white, you're basically adding to the overall albedo effect to reflect sunlight energy back into space. So this space it's called a principle of passive building design that uses natural sources, including wind, solar energy, and daylight to reduce the amount of energy buildings consume. Is being updated, extended, and providing useful lessons and some fruitful benefits already. We're in places where such methodology is being employed. So wanted to bring that story with you along with increasing the warmth of the planet, we increase the demand to stay cool. Because I think when the temperatures hit about, I think it's 33 degrees C, that perspiration alone is insufficient to keep you cool because of the water vapor content of the atmosphere is not able to whisk the moisture off your skin, right? Evaporative cooling. And that can lead to health issues, and elderly people have developed issues with circulation and thermal regulation. They're at increased risk of heat stroke, death, and so forth. And and it's just overall just an unhealthy situation. So we're trying to keep ourselves cool while we continue to warm the planet up, and keeping ourselves cool will burn the materials that will increase the temperature of the planet. It's a nasty positive feedback loop. Hopefully, though, with what I just described with you, with new methodologies and new ways of constructing, new materials being used, we can at least reduce the energy required to keep places comfortable. Thank you for your time. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.